Hi, my name is Regina, and I'm going to present our workstation in an automotive assembly line to make it smarter, ergonomic, and aligned with Industry 4.0. So for our initial state, everything was very manual and limited automatization, and as we can see here, our prototype was based off of Legos, and it was really still very Industry 3.0 because, as I mentioned, some parts were still manual and there were many repetitive tasks and it was mentally tiring, so that also led to mistakes and slow inspection speed and low efficiency, for example. So based off of that, we made a diagnosis to identify improvement areas, and we use different tools, like for example here we can see mapping or tools like a flow diagram that help us see how worker fatigue, posture, and inspection delays were hurting quality and productivity specifically. And our metrics were like, for example, inspection time per batch, error rate, failure percentage, and we based off all these things based on the company's missions. So it was efficiency, safety, and quality. These were the key to track. So for our design, we also strictly focus on ergonomics. We're using anthropometric data to the 95th percentile to set, like for example, height, width of the workstation in general. And also we designed like natural postures, included many factors in our simulation, like anti-fatigue support to reduce strain. And we also follow norms 036, that is for ergonomic risk, and normative 035, which is for physiological safety. So everything that was a problem before, like repetitive tasks, we try to reduce them and reduce stress and cognitive load. So now talking about Industry 4.0, which our prototype wasn't there yet, we decided to implement these two technologies, which was IIoT and digital twins. The digital twins let us simulate the station and predict all the problems before they actually happen, so before making it. And the IoT gives us the real-time feedback from the sensors like the size detector and monitor sensors, which together help us in general to reduce human error and improve trackability and train operators better using, for example, simulations. We also align this to Human Factor 4.0 by integrating the ergonomics as a layout of comfort, the real-time feedback to support decision-making, and the training system with virtual tools to upskill operators instead of replacing them, because that is also helpful because the system that supports both performance and well-being, just not performance. So for our final implementation, we built a prototype using Arduino, sensors, conveyor belt, Python integration, which is this photo right here of our physical prototype. We also, with the help of Technometrics, help simulate a human-machine station to validate productivity, improvements, and monitor real-time data performance. And this new system is more scalable, precise, reduces inspection time while also protecting the operators that work in our assembly. So in terms of compliance, sustainability, and ethical responsibility, we follow the STP norms, which I mentioned before, to ensure a safe environment for everyone. From a sustainability perspective, we reduce waste with the smart classification and minimal physical prototyping. And in an ethical way, we address job displacement by focusing on operator training and getting them along with our inclusion to the transition Industry 4.0. And it was basically just focusing more on our operators going with us than instead of just displacing them. So to finish off, this project showed that redesigning a workstation is just not about adding tech, it's about planning and putting people first. And also by merging, like for example, ergonomics, productive tools, and Industry 4.0, we created a solution that was more efficient, safer, and sustainable for everyone.